Okay, so another way we can solve quadratic equations is by using the square root property. And so the square root property says if you have a squared equal to b, then a equals the positive negative square root of b. And so, for example, if I said x squared equals 9, x could equal 3, or x could equal negative 3. Both of those would result in 9 after you square them. And so we could solve this equation, x squared equals 49, using that property. X equals positive negative square root of 49. Square root of 49 is 7. And so x equals positive and negative 7. And so you have to remember, there's usually two solutions, and so you can't forget the positive and negative case. Here we can use that property. The expression x plus 13 squared is 250. And so using the property, we have x plus 3 equals positive negative square root of 250. And then we can break down 250 into 25 times 10. Which means we can take a 5 outside the radical. And so x plus 3 equals the positive negative 5 square roots of 10. And so we still need to isolate x by subtracting 3 from both sides. So I just move it to the other side and make it negative. And then our final answer would be negative 3 plus or minus 5 square roots of 10. You can write it separately if you want to. One is plus 5 root 10. The other would be the minus. Okay, and so the point of doing this is because if we were to solve this by quadratic formula, we would first have to FOIL this out and then move the 250 to the other side. And that takes a lot of steps, whereas if we just use the square root property, it saves us a lot of time. And so whenever you have this setup where you have a perfect square equal to a number, you can use the square root property. And so we need to get this set up. And this is called the perfect square trinomial. And so if we're not set up like this, we can rearrange our equation and set it up like this. And so we need to be able to recognize our perfect square trinomials. And so here, this is a perfect square trinomial. It factors to x plus 4, or we could write it as x plus 4 squared. Here, it would be x minus 4, x minus 4. This one would be x plus 7, x plus 7. And this would be x minus 6, x minus 6. Looking for two numbers that multiply to positive 36 and add to negative 12. And so that would be negative 6 and negative 6. Two numbers that multiply to 49 but add to 14 are 7 and 7. And so that's how I was factoring these. And so a pattern you may notice is that the number inside the parentheses is exactly half of your b value. Half your b value. Same sign and everything. Okay? And then the c value is that number squared. Okay, and so this 16 is half your b value squared. Half your b value squared. And so if we don't have that setup, we need to create that setup by what's called completing the square. We would find our b value, we would cut that in half and then square it to get our c value. And then our factored form would be x plus half the b value squared. Okay, and so if I wanted to solve this equation by completing the square, we need to add that new c value. And so you set your quadratic equal to the constant. This is the only method where you're not set equal to 0. and you're going to add a new c value. And you can't just add a number to one side of the equation. You have to add it to both sides to keep it balanced. And so the number you add is half the b value, and so in this case, half of 6 squared. Well, half of 6 is 3, and if you square it, it's 9. And so 9 is the number we're adding to both sides. And then the left side factors to x plus 3 squared. And then the right side simplifies to 25. And now we're set up to use the square root property. So x plus 3 equals positive negative square root of 25. And we know that's just 5. So now we can move the 3 to the other side, and we can write our two cases. We have negative 3 plus 5, or we have negative 3 minus 5. Remember, whenever your discriminant is a perfect square, that means you're going to have two rational solutions. And so you need to simplify all the way to those rational numbers. And so my two solutions here are negative 8 and 2. Okay, for this next one, same thing. We are set equal to our constant. And so we're going to add a new c value to the left and the right. Okay, and so half of b would be 4, and then we square it to get 16. And so 16 is the number that goes in the box. And so that means the left side is going to factor to x plus 4 squared. And the right side simplifies to 36. So using our square root property, we have a perfect square, so we're going to get rational solutions. And then we slide the 4 over, so it's negative 4. And then break it into our cases, negative 4 plus 6, or negative 4 minus 6. In this case, we get 2. In this case, we get negative 10. So negative 10 and 2 would be our solutions. Okay, on this next one, we're not set up yet. We need to get the 8r over here. So it would be r squared minus 8r. And then we need the constant to the other side. So that would be negative 14 once we move it over. This is the only form where we set it equal to the constant instead of 0. And so now we can add in our boxes, both sides, keep it balanced. And then half of b this time would be negative 8 over 2, which is negative 4. And then we square that, it's positive 16. So 16 goes in that box. And then the left side factors to r minus 4 squared, half the b value. And then the right side, negative 14 plus 16 is 2. And so we're ready for our square root property. And this time we don't have a perfect square, which means we're going to have irrational solutions. Square root is going to be in our final answer. So the best we can do is slide the 4 over. And that would be our final answer. We have 4 plus the square root of 2 and 4 minus square root of 2. We don't get nice rational solutions on this one. It does stay simplified, whereas quadratic formula, we would have to do a lot of simplifying to get to these final answers. All right, this next one, we just need to move the 6 over to the other side. So now it's negative 6. Make room for the boxes. And so half of b this time would be, would be 1. And then we square that, we still get 1. And so here, the left side factors to x plus 1 squared, and the right side simplifies to negative 5. And so when we use the square root property, we see that we have a negative discriminant, and so we're going to have some complex solutions. And so we need to take an I out of the radical. And then view the positive 5. And then for our last step, we just move that 1 to the other side. And these are our two complex solutions. One is -1 plus I root 5, and the other is -1 minus I root 5. And so completing the square works really nicely when your b value is even, because we end up with whole numbers to add to each side. If your b value is odd, you can still complete the square. You're just going to have to deal with fractions. And so here we do the same setup. Move the 24 to the other side and make room for your boxes. Okay, and so we cut 11 in half and square it. And so because it's a fraction, you just square the top and square the bottom. Okay, and so 121 over 4 is the number that we are adding to each side, but this is still considered a perfect square trinomial. We still cut that b value in half for our perfect square trinomial. And then to simplify the right side, we need to get a common denominator, and so we would multiply top and bottom by 4, and that would be -96 over 4. Plus 121 over 4, which is 25 over 4. Okay, and so I'm going to rewrite that here before applying the square root property. And so now, using the square root property, we have a plus 11 halves equals positive negative square root of 25 over 4. And to simplify a fraction under the radical, you square root the top and square root the bottom, just like we did with the squaring. And so this simplifies to positive negative 5 over 2. Still a perfect square. And so now our last step is to move the 11 halves to the other side. And because we had perfect square, we're going to have rational solutions. These are going to be numbers without square roots. And so one case is -11 halves plus 5 halves. The other case is -11 halves minus 5 halves. So in this case, we get -6 over 2, which is -3. In this case, we get -16 over 2, which is -8. So nice integer solutions here. And you would get the same thing by factoring or by quadratic formula. This is just another method. Okay, and so for this last one, it's set equal to 0. And so honestly, I would just factor out a GCF. Both of these, you could factor out an x, but if we're completing the square, we make room for our boxes, and 0 plus that box is just going to be that number. And so half of b squared would be 25 over 4. Okay, 25 over 4. And so the left side factors to x plus 5 over 2 squared. And the right side is just 25 over 4. We're ready for the square root property. Which simplifies to positive negative 5 over 2. And so x plus 5 over 2 equals positive negative 5 over 2. Slide the 5 halves to the other side to combine with the other 5 halves and write your cases. So negative 5 halves plus 5 halves would give us 0. Negative 5 halves minus 5 halves would get us negative 10 over 2, which is negative 5. And so our solutions here are 0 and -5. And if you had solved this by factoring, you would have just factored out an x. And then setting your two factors equal to 0, you'd get x equals 0 as one solution, x plus 5 equals 0 to give you the -5 as your second solution. So multiple ways to work these quadratic equations.